Okay, so let's talk about what the content today. So for today, I'm going to be going over the AWI, or Autodesk Water Infrastructure products. We will then be moving, Jason will be taking over and taking you through the Infra Water Pro products. We'll be talking about the different tools and then talking around the integration between the Autodesk products and Esri ArcGIS Pro. So where does the product come from, and how does the Autodesk solution look in terms of the vision that they've got for the full water life cycle? And when I was thinking about this presentation this morning, something came to mind was if we think back to architecture and design and we think back to structures, 20 years ago, we were all using AutoCAD and we were drawing a lot of products and we were doing what we'd call today non-intelligent documents. And the vision that Autodesk has for the water life cycle is to start building that smart, resilient and solution-driven products into our water cycle. So moving from 2D, where you'd be drawing your designs in something like Civil 3D, moving to a database structure where every object that you're putting into your design has information around it, and building a digital twin, essentially, or building the blocks that can be used for a digital twin later in the design process. So when we look at the water cycle, every part of the water cycle is touched in some way by an Autodesk product, whether it is in the design phase where I want to see and analyze asset models in terms of their geospatial content, whether it's in the build where I'm collaborating with my different people involved in the process, making sure that the solutions that I'm putting in place and building are spec to the right requirements. When it comes to operating these projects and making sure that the operations are running smoother. If I haven't designed it correctly and I haven't built it correctly, I cannot operate. And if I don't have that intelligence flowing through the life cycle, I'll never be able to monitor the performance of my buildings and my water structures. And that will then influence the planning cycle again, which will go back into the design and the iteration of the product. So the outcome that Autodesk is trying to drive is a full cradle-to-grave life cycle of data through the process. In terms of driving the digital cloud, digital transformation from cloud to sea, Autodesk envisions that life cycle where we start at the planning process, where we're involved with your owners, your engineers, and your capital projects. We move through the design process where you move over to your engineers, you move into your construction and your building process, and then back to your operators and maintenance. So Autodesk solution covers all aspects of this, whether it's in water structures, storm and flood, sustainable drainage infrastructure, water distribution, sewage networks, and then, of course, wastewater and treatment plants. This is a very important stage for us because we will able to touch your solution at any point. And we have a solution that fits for every single person that's involved in this infrastructure discussion. So if we look at the product offerings that are in the mix, we have product offerings from our traditional stable, where you'd be looking at our InfraWorks and our Civil 3D and Revit in terms of the actual structures, moving into things like Recap for your point clouds, into the more advanced technologies like your Infra Water and your Info 360 product offering. But I'm not going to talk too much about that today. I'm just going to say to you that we have solutions for every role in every single engagement that you have, that you will be able to use an Autodesk product to fulfill those requirements. If we break it down into key solutions, we have our core distribution products like we have in the ACC construction products, where we would have tools that are running on your desktops. These are your info drainage, which is for your drainage design. So if you've got customers or you have requirements for designing optimized networks to mitigate floods and regulatory compliance, then info drainage is a product for you. InfraWorks ICM is your storm, sewer, and flood tool. This is where you do your simulation of drainage systems and sewage collection services. Then we have our water distribution, where today Jason will be taking you through this, where we're starting to model water distribution systems to make sure that we meet your service level requirements and deliver clean, portable water. On our SaaS or cloud solutions, we have this is where we go into the actual operations and management of facilities. This is where we have two or three products, which is Info Assets, info insights and info plant. And these are the very deep technologies which allow you to actually run the facilities that you've designed and built using our technologies. Today, there was an interesting article on Daily Maverick talking about over 30 million liters of sewage that is being leaked into the Yukskay River as we're talking. If we had these solutions in place and we were using these technologies, we would be able to address these and make sure that we will find the root cause and make sure that we're able to put sustainable solutions in place for the future. But without further ado, I'm going to hand over to Jason, and Jason, you can take us through the products.
Fantastic.
And I'm going to enjoy some coffee.
Thanks, Simon. Much appreciated. All right, so from here, we'll just start looking at a bit of the technical inputs of what the software actually does and what are we actually working with. So let's start having a look at InfoWater Pro for the pros. What does InfoWater bring to the flow? So just as an overarching idea, we'll start looking at the key elements. So when we start looking at the water distribution networks, we are looking to obviously increase our performance and efficiencies through everything that we do. Now, InfoWater Pro is built into the ArcGIS platform. So this just makes the GIS data management so much easier. Integration between the different Autodesk solutions, it's now directly built into ArcGIS Pro. So we can gain efficiency in building and managing these models directly within the GIS environment, collaborating and effectively building and managing models. So this is where we'll start leaning on the Esri products, where ArcGIS allows us to have one single database project file. And this allows multiple users to work off that single project domain. And from there, that just allows us to maintain accuracy on the models that we're working with. Then we also understand operational impacts with 2D and 3D visualizations. So this is where we go back to, like Simon says, with the operationals, where once we've built this network, who is maintaining it, making sure that the system is functioning as expected. Now, with this, we also go over to the analytic portions of InfoWater Pro. So we can do nice fancy analyses like flushing of the networks and water quality analysis. We will go into a bit more detail soon. We even have elements such as surge analysis. So within the South African market, we know that is a big demand. It is normally very specialized and unique software packages that cost so much, where InfoWater Pro has seen the need for that, as well as WS Pro, and they've actually integrated that into the software application. Then we'll even look at running fire analyses. So this can either be a single flow or multi-flow fire analysis, checking all the hydrants. If we want to be having multiple hydrants firing at once, what does that actually look like? How does that affect the network as we progress? So from here, this is now going into the finer details of understanding how we actually work within the GIS domain. So the GIS domain allows us to access data from existing as-built information. So whether we're working with building information, statistics, as-built layouts, even cadastral data and historical data, that is directly available through ArcGIS, which makes that incorporation of that information a lot easier. You don't have to go pay anyone else to go find that information or use that information. You already have those licensing. Then we can start actually creating the 2D and 3D visualizations once we have analyzed these networks. So from here, this will allow us to actually take the results from our analysis and actually visualize that into the network, whether that be from a flow wave to actually just showing different variations of pressures and pipe sizes. Then with regards to the flushing water quality analysis, now, this is where we'll actually start looking at running different type of water quality analysis, like a trace analysis, being able to identify the source of one of the pollutant factors. If you are doing that, so anything like chlorine, then we can even do temperature analyses to see, all right, we specify a constant temperature onto this network. And if our SCADA data system and the telemetry data picks up deviations in those variables, we actually get warnings and system updates to tell us what is happening, as well as then looking at if we've done simulations for preemptive designs and being able to be proactive and not reactive with the network analytics, we can then see that as soon as that actually happens. Then with the surge analysis, this is where we'll start actually looking at the wave propagation factors within the software. So how does a pump trip cause a wave propagation through the network, and how is that going to affect our junctions and our joints? to which areas is this going to propagate into. You know, we might be worried about further down the line how that is going to just increase in efficiency and multitude. And then with regards to the phi analysis, so the nice thing about the phi analysis is we don't have to analyze each hydrant one by one. This actually allows us to specify the flow for all hydrants, and we can actually then run a simulation that runs all theoretical possibilities with all hydrants simultaneously. So it removes that need to run multiple analyses after one another and then compound that information as we do those analyses. So with the leveraging of the GIS database, this is just where we can see how we have a lot more user compatibility when we get to collaborative workflows. So even if we're not sitting in the same office, we might have people from different branches that may be working in Cape Town, PE, Durban, wherever it may be. The database format of GIS, ArcGIS Pro specifically, that allows us to maintain one single version control system where the system itself actually controls the master control drawing or database. And as users make changes, that master system then reads what changes are being applied from what users, and then it will then decide which is the most up-to-date and latest changes that have been made. Now, we can even start accessing live layers from ArcGIS online, where we can actually then bring in those web maps, whether it be aerial photos, contour data, building outlines, or any existing services from there. So this really just collaborates a lot better than what you are using 3 different external third-party softwares. This just brings everything together within one working space, because we have seen that when we start importing, exporting, this is where we have a lot of these human errors. We have inefficiencies with version controls and tracking of what data was sent through, where this allows us to track all of that live within the direct model itself. So we're keeping all the information together. Now, like Simon mentioned, as we move over to the operation side of things, we can connect to telemetry data. So we can use anything from Pi to SQLs, ClearScaler data, and even Oracle SQL servers. So we can start actually implementing live data feeds, whether it be metered connections, to actually be able to effectively cost clients for any water used. We can even look at any sensor data, like I mentioned earlier, with regards to pressures or any chemical tracing, as well as then being able to even just have standard sensors for pressure and flow. So we can even start looking at identifying any bursts in the network or leakages. Are there any planned maintenance that should be taking place on those sensors? And then even being able to sensor and check data from fire hydrants that need to be flushed to get the system clean. Now, with this, we can graph the live data to our actual model in real time. So using ClearScaler data or even accessing the data through the Oracle servers, we can actually see what our model is predicting to happen and what is actually happening on site. And if we have any deviation between those 2 variables, so this allows us as the users to create a lot more accurate model to get as close as possible to that live data that we are seeing. Now, once we have this live data feed and we've got our network to where we need it to be, in the balancing principle of what we are projecting is what we are actually seeing from the sensors. This will allow us then to take the sensor data and be preemptive with it. We can then start designing or planning for worst case scenarios or bad situations. If something should happen, what is going to be our solution to that? Now, the telemetry data also allows us with the Info 360 portions of this to actually send data to a communication center. So if we have response teams that are available that we can send out should a burst happen or we need to flush a hydrant system, that we can actually send them out within the correct time frame, that we can actually get that resolved as efficiently and timely as possible.
So sorry to interrupt you, Jason, but like in the area that I live in this week, we had a pump change, and that caused the fire hydrants to break. But there was no way of knowing that. So this would have been able to support that. So if they'd used our technology, they would have been able to say, we're going to change this pump. And that would affect this, is that correct?
That's exactly it.
So they could have preemptively sent people to fix those before they burst and wasted all the water.
There we go. And then what makes that even better is even if it did burst and it was an accident, the nice thing is being able to identify where that hydrant's even located geographically would have made their jobs easier. Instead of having to go find old council submission plans and then having to page through those, we'd simply open up the model. You'd be able to give that guy the house number that the fire hydrant's in front of. So that just the response is a lot quicker and the downtime is a lot more effective. So perfect example, yes.
Would have really helped us this week.
Fantastic. So that's where we'll start moving over to the post-incident analysis with the most realistic models. Now, when we look at aiding in speed and calibration, InfoWater Pro as well as InfoWater WS Pro, they actually have aiding tools within the software to help us make sure that the calibration of these sensors are obviously intact and what they need to be. Because if we're not seeing the right data, we are making the wrong choices. So it comes back to the old saying, rubbish in, rubbish out. So we'll just need to make sure, and InfoWater Pro is there to help us with those parameters. Now, like we just said, this allows dynamic modeling with that live data. So we can even use this information and take the sensor data and publish that to a dashboard into elements like Info360 assets, where we can actually see what is happening to those live elements. So this is where the operators of the system would be able to see, all right, we've got a fluctuation in pump 13 happening at the moment. So we're expecting a drop over here anytime soon, or we need to do preemptive maintenance on this. So that's exactly where this software flourishes and actually stands out the most. Now, even when we have this live data, we can even have the live data update our model. So should we be seeing parameters out of range, we can have warning systems come up and warn the operators in time to tell them, right, we have a problem over here. We have preemptive measures. We've hit our first warning point. Are we actually going to go over into the breakages, or are we going to apply a second warning point, which is then like a critical alert? So these models can even interact with the live data and warn the operators of what the model is actually doing with the data that we are seeing. Now, this is one of my most favorite portions of InfoWater Pro when we go over. And this is, I always love this little saying or the word that I've seen before, optioneering. Now, we can use scenarios within InfoWater Pro. Now, many times we have in the past had to create multiple different models for different scenarios. Now, scenarios within InfoWater Pro allow us to just maintain one true model, but have replica databases of that exact same model. So we can replicate different scenarios of how that network is actually generated. How is a pump functioning? Are we actually working with different pipe diameters? Are we actually working with an entirely different network where in one situation, that node can be a fire hydrant, but in the next junction or the next model, that is then supposed to be a isolating valve. So the control with one model allowing us with different scenarios, we can then take that model and keep that efficiency of knowing that the information on the design data is true when we look at layouts, pipe sizing, and anything like that. But then with the scenarios, that allows us to give us that if, but, and when situations so that we can have a lot better understanding with the network. So instead of having to recreate an entire network, we can just simply create a new database, update the information, and actually see what happens and what does that actually do to the network.
And how long does the sort of optioneering run? Is it a long process? Is it a quick?
So that's a fantastic question. So that gives us different parameters. So it depends on the network itself. So that's the fantastic thing about InfoWater Pro as well, is that we actually have a whole new engine brought into InfoWater Pro and the whole AWI package. So even if we go over to ICM or Info Drainage, that same mechanical engine is still there. So what InfoWater Pro and AWI as a whole have gone and done, they have actually taken the standard EPINET engine and they've actually just added their own additional improvements onto that. So normally because we look with large models, we might be looking at towns or cities that we actually work with in these database formats, that the processing takes very long. So we have experienced, if we use a software like Civil 3D, for example, if I had to analyze this within Civil 3D, those size drawings might take up to hours.
Yeah.
We might look at 6 to 8 hours. Now, just using the built-in mechanism within InfoWater Pro, we can cut that down to less than 12 minutes, maybe even 8.
Brilliant.
So And then we can even take it one step further, and we'll take it from our local drive and we can actually send it up to the servers and actually have a server simulation take place and run that analysis for us, which will take the 12 minutes and cut it down to under 2. So yeah, we do have those options available for actually computing these large networks a lot better than what we were able to do. Now, like I mentioned, the optioneering with the scenarios, that allows us the integrity for each alternative that we are working with. And we can then take that same network and create different scenarios in which we want to analyze anything like our surge or transient flows, our fire flow situations, and our water quality, because we can even track the stagnation of the movement of the water within the pipe. So we can make sure that if we have an area that's got slow movement throughout, that might need to be a system that needs to be flushed a little bit more regularly than what we do down further north on the main line, anything like that. So now we'll go into this finer details of what can you actually analyze when we look at water quality. So starting off with our multi-trace analysis. So this is where we can start tracing any pollutants that come into our system. So like we just heard with the wastewater that's going into the Eske River, that is just unacceptable. So now we've gotten into a situation where we need to be reactive, where we weren't proactive. And this is something like where the water quality system could come in to say, all right, fantastic. We might be seeing these pollutants entering the river, but where are they coming from? And this is where we can actually then generate a model and start tracing these. Now, whether it's a single source, like the wastewater, but we can even do a multi-trace. So if we try and detect, all right, but we see we've got wastewater, but we've got high levels of chlorine or hydrochloric acid, all of these reactive or even non-reactive elements that may just be filtering through the network, steel particles, anything like that, we can actually set those parameters and the network will be able to tell us and show us with the flow that we are receiving into this network. If we back engineer that, then we'll be able to then trace that to the source. Now, we can even trace that back to the source, and we can actually see that movement live within our network. So if we now see, all right, but for some reason, we don't have flow down the main line, but we actually have a diverging flow, what can be causing that, and why are we actually getting that divergent flow than what we are expecting to see?
So just on that, so if we find someone for putting chemicals into a water source, we can actually then trace if they've stopped.
That's correct.
Okay, so that's really interesting. I think that's something that's missing from many of the models I've seen.
That is so true, yes. And that's another element that is just that little bit more of a niche that just gives us that upper hand over all our other competitors, because you can say with confidence and give that as another service deliverable to our clients, as well as just even keeping that in mind for your own analysis. So yes. Now we can even take this over through to the temperature and water age, so where we had that stagnation. And then we can even take this one step further. And if we want to be, once we have located the source, when we need to determine where within the source, so let's say, for example, we're looking at a tank, water tank that's being fed from maybe 2 different reservoirs. How can we determine from which reservoir is that coming in?
Yes.
And that's when we'll start looking at factors like our tank mixing. So there are different methods that take into account how a tank actually functions with regards to our inlet and outlet pipes. So are we doing a FIFO, first in, first out? Do we have separators within the tank where we might have a FIFE where we have first in, last out? So we can then trace how that turbulence within the tank actually takes place and mixes those chemical processes, allowing us a better understanding of where to go look and trace this pollutants. Now, next up, we have our transient or surge flow analyses. So this is something that I know, especially within the South African market, is, I won't say we're a bit behind, but it's very difficult to get access to this type of analytical software, and that can be quite pricey. So once again, this is built in. Now we can run the surge analysis by taking a tank or a pump and tripping that when needed, and we can actually see how that pressure wave functions through the network.
And this is what you call water hammer.
That's correct. Okay. So the normal term would be water hammer, yes. Now from there, InfoWater Pro even allows us, even though we don't know the wave speed that may be propagating through this, we can actually apply parameters and calculate what the wave speed should be for our given network. So even if we don't have live SCADA data that we are able to use to then find those values, there is a calculation that we can run within InfoWater Pro. So all the parameters that you need to input are also within InfoWater Pro. So you don't need any third-party software to get data for an input value into InfoWater Pro. This is a one-stop solution from beginning to end, and that will give you the confidence. And it will actually go into so much detail that you will actually go back into the mathematical portion of these. So it's really, really fantastic. Now, the surge analysis also helps us by being able to identify where can we best place or most efficiently place these protection devices. Now, we know that, yes, we want to stop water hammer, but unfortunately, we know it's a thing that won't disappear. It's always going to be there unless we are able to identify these further into the future, but that is so difficult with anything mechanical. Stuff fails and it happens. So these just allow us to place protection devices where needed and even preemptively add, so should something happen, that we have a backup plan for that. And this just allows our system longevity and sustainability just to go that much longer, so that we actually keep the system and network health available for as long as possible. And then just for those that might be interested, the surge analysis solves the basic conservational equation of fluid mechanics through the transient flow of an incompressible fluid within the pipe network. So just a bit of technical details for those that are interested. Now, I just want to show you guys a little short little demonstration of how we are actually able to take a surge analysis and actually run that as a simulation value. So this is where we can start seeing our scenarios. So on the left over there, that is where you can see all the different available options that we have been able to generate for that one single model that we're actually viewing at the moment. So at the moment, he's just generated a new scenario, and this is the physical run manager. So in this window, we can actually see at the top of the tabs, there is the whole host of available analyses that we can run. So in this scenario, we've actually simulated a pump trip, and we can actually start seeing how the surge protection devices throughout the network has started working its way in and bringing that network back to a standard flow, so that we get rid of the transient flow actually happening throughout the network. And then this is how we can actually see and compare data to one another. So we can take multiple surge scenarios and actually compare the two between different scenarios and actually have an outlook and see what is actually the right answer, what is actually helping with our protection devices. So just as a quick view, we can see that that red line is a lot smoother and a lot more stable than that green line at the bottom. So with a different input value, we can see that we've stabilized that network a lot sooner and easier. We get back to the visualization. So there we can see all the fire hydrants that were running at the same time, and what are the actual pressures running through those and the flow rates happening.
So in that scenario, you could take an issue that happened in the past, and then you can do scenarios of how to address it and how to fix it. Or you could be preemptive and say, if this dies, if this pump stops working, we can then look at what the best way is to stop that happening again.
That is true, yes.
Okay.
And if that should happen in the future, what is going to be our preemptive measures to stop that from happening? So even if we do have the situation happen in the future, we might want to open up a bypass valve to then allow that pressure to just deviate and bypass around that, which is really, really fantastic. Next up, we now have the fire flow analyses. So this little screenshot over here that I want to show you is actually one of the scenarios where this was actually run within the simulation on the cloud. So in the scenario, we had a bit of a master plan, and we had close to, if I'm not mistaken, it was like 1,000 to 1,400 fire hydrants. And we wanted to run different scenarios to say, all right, we want to have either one fire hydrant firing throughout the entire process. So it went and checked each hydrant individually. And then we started running multi-flow analyses where we actually started picking key locations where we thought our pipe network was too small to actually get that 5-flow pressure through it. So we actually had multiple hydrants firing at the same time. And this gave us a better global understanding of our network. Is maybe one of our feed lines from a reservoir, the bulk line's too small? Should we have a situation where even though it might be 3 districts away from one another, but that still has an effect on the network if both of those hydrants are firing at the same time? Now, instead of doing that locally on the local machine, which would have maybe taken 8 hours or so, even with InfoWater Pro, we then rather decided it's going to be more beneficial, just send it up to the cloud. We can carry on processing with the next task that we need to do. And this will just, as we get these updates of each an analysis that has successfully been performed in the message bar below, fantastically, you'll have successfully updated. And then you can go back and just view those results and take it from there. So I also just once again have another little demonstration of how we can then use this within the cloud. So once again, this is where we are just, now you can see we're under the standard 5-flow scenario. And this is where we can see those simulations happening, where it will actually give us an estimated duration. And you might even see that even if it pops up the first time as a 3-hour duration, you might see that drop instantly from 3 hours to 1 hour to 20 minutes and then down to like 10. So it's just making sure the network servers are able to get all the information required for these flow analyses. So from here, we can now see how the data is directly, once we run the analysis, the output data is added to those output fields directly onto the direct junction elements. So this allows us a dynamic feed that we don't have to go and generate information. The information is already placed. We just need to know where to go look for it, extract it, and use it as needed. Now, this is where we can have a bit of visualization. So in this example, we can now see how those hydrants are firing. And we have now created a condition to say, all right, which ones are in most critical conditions? And then we isolated those colors. There we go. All right. So then last off, I just want to finish off just with a bit of a case study that we've had with one of our large clients within the US. And I just found it very fascinating. And I think this will be very beneficial for you guys to be able to see what can actually be done with the software, not even just with InfoWater Pro individually, but AWI as a whole package. So this is where we can see how AWI is not just focused on one discipline. We are looking across multiple disciplines. So this is where we can have a look at a bit of the future proofing. So this is where they were actually doing preemptive designs to see if something should break, how we're going to resolve this, how we're going to get the right staff out to site to actually get these problems resolved on time. So this is how we can see how we start using the Info 360 Assets dashboard to actually take our live data model and move this over into the operational aspect of things and making sure that the right people are notified at the right times, whether it be for maintenance or repairs.
That's what my neighborhood looked like this week. We had 4 burst.
Jeez, like... No, luckily this one was planned. So they actually made sure that they were able to plan with the municipal council to actually get the guys out to perform the flushes on regular times when needed. And then this is where I just want to, I found this so fascinating, where the higher level management within the company, even though this software doesn't benefit them onto a day-to-day basis, their staff are able to come back to them and actually identify critical locations that is going to be most important for the next financial year, and how we are going to look at allocating these budgets to making sure that we actually get the system progressively fixed. And not even just fixing it, but maintaining it. because I know that's something that we all understand within our current economy, is that is something that is lacking, and that we actually just playing catch up on at the moment. We are just making sure that we are fixing everything that's broken. We are not even preemptively working at that stage yet to replace what is going to break. So, and I think this is one of the biggest software packages that can help us get that moving forward and get ahead of the curve on this. Fantastic. So that's everything from my side. Simon, anything from yours?
Yeah, I think, when we started the discussion, we spoke about, I spoke about the ability for, that this will be the BIM of water.
That is actually good comparison.
Yeah, so taking, we're moving from a static 2D drawing, we're moving to a 3D object and a 3D drawing into information management, and we're starting to manage the information around this. And you mentioned earlier about the interoperability between products. If I look at a guy today that's doing a water project, they're using probably 7 different technologies.
That's pretty much,
So they've got Autodesk products, they've got products from Bentley, they've got products from other water utilities, and they're trying to hodgepodge this all together. They've got SCADA data. The Autodesk products and what you've mentioned pulls all of that into one platform. So you no longer have to break out. So if you want to do simulation, you use a simulation tool. If you want to do something else, you do this in the same platform.
That's exactly that. Yeah. Because you've been able to realize that as the software has progressed throughout the years, all packages, CAD packages, have started off by specializing in their field, because we've gone over from this digital transformation of taking it from pen to computer. Now we are now in the next phase of where we're moving away from specialized software to all-encompassing software. And I think that's where Autodesk is actually ahead of the trend at the moment, where they've realized that it is not effective to be working with individual software packages. Let's combine everything, because that gives us a clearer mind and less human error between those integrations.
Yeah, brilliant. And especially the fact that you've got multiple users working on the same version.
That is fantastic.
You don't have this problem like we used to when we were doing drawings on construction sites. It's the drawing that goes on site is the wrong version. And then you have this whole breakdown in communication and change orders.
There we go.
If we have one model, we're all working on the same version of truth.
That's so true. Yes.
So I'm just going to go through some of the questions. There were a couple of questions that came in. The first one is, where does one start if we want to use Autodesk Water solutions? Where would you start?
So that's going to be a bit more specific to your discipline. So I would say just start having a look at, if we look at the AWI package, just started focusing on your discipline. So if we're looking at storm sewer, that would be in something like info drainage. If you want to be preemptive, we might even look at going over to an ICM, because of that of a 2D and 1D surface flow flood analyses and stuff like that. So mainly identify your needs, and then from there, look at one package. Start with the one package, and then we can expand further. Now, if you are starting with multidisciplinary, it might even just be more beneficial to start with a package, the entire package, and break it down as you just upskill in the software. I think that would be the best course.
Cool. And of course, come and chat with us and we can help you pick the right tool for the requirements that you've got. We spoke about sensor data, and we said that, InfoWater Pro gets sensor data into the model. Can you just elaborate on how that happens and what process we follow there?
All right, fantastic. So with the SCADA data, it is quite, well, in IT terms, it's quite simple, but we basically just take the live sensor data. That sensor data either goes into a preemptive server or a little box in between that relays that across to our server database. So we'll use something like an Oracle server, set that up, and the data then goes straight to that Oracle server. And from the Oracle server, we can then use Info360 assets or anything like those to have a live link to that data. And through that web interface from Info360, we can then have that tool to access it from InfoWater Pro, go fetch that information, and that is how we then bring it into our model.
Okay, brilliant. So the next question was around, how does InfoWater Pro handle different scenarios and what-if analysis? How can this be used for emergency response planning in a water distribution network?
Fantastic, great question. So that would just come back to a scenario like we had with the fire hydrants and the pump stripping, where we could now, like I mentioned earlier, we can actually identify, all right, our sensor data is telling us I've got a leak on 12th Street, but I see that the leak is propagating further down into 14th, where I actually see where the root cause is or where the hydrant blew. So because of that, I can now dispatch my response team to go to 12th and 14th directly, instead of going to drive up and down streets asking residents where the water leak is.
And also, I think, like And I'm thinking about issues that we've had in South Africa. If we look at the big fires in George and places like that, we could have done scenario planning to say, if we have a massive fire, we could have, what happens if all of our fire hydrants are running? What is the pressure on the network?
Yes.
How do we plan better to say, okay, if we're dealing with this, only utilize these in these scenarios, so we could actually get our response teams to be better prepared for when they go into issue areas as well.
Yeah, we can actually preemptively train them into situations like that to say, all right, close these isolating valves, get more pressure and feed to these. So that is definitely, and this allows us to start that planning process.
Okay. And then the next question is, what is the ideal projects that InfoWater would be used for?
So because InfoWater Pro is GIS based, database based, this is going to be our large networks. This is where we'll do any form of master planning. If we are doing an upgrade system for, let's say, a 3,000 to 5,000 unit residential development, these are for larger models. So it won't be something small that is just going to be for one or two properties. That is going to be the main focus of these.
So the sort of target market would be operators and owners of water networks.
That as well, yes. Government entities, if you may be running the operations like you mentioned, anything like that.
Okay. Then they asked, what sort of types of scenarios can you do using InfoWater Pro?
So that would be looking at the different type of analyses. So that would be going back to our fire flow, our surge or transient analyses, the water quality. We can even have a look at the water age. We can do the pollutants. That's about the main things. What else should we can do pump tank levels controls. We can do reservoir leveling controls, all of those.
Okay, so all of the things that people would be using that they'd use for their job would be in the software as well.
That's correct, yes.
Okay. Another question is, how do we import GIS data into InfoWater?
Oh, fantastic. That's luckily it's built in. So that is literally just going to be your insert button. And whether you're pulling that directly from a local source on the machine or whether you're accessing it from ArcGIS online, that is directly built in. So there's not actually even importing anything. It's just telling it to go fetch it and put it in my drawing. Yeah,
so one of the main things that InfoWater has been built has been built around that interoperability with GIS, and that is seamless. There's teams between Autodesk and Esri that are actually working on this product live at the moment and developing that. Then the question is, can we share models from other Autodesk products like InfoWorks or Civil 3D?
Oh, definitely, yes. So even if we start looking at a single development and we might be coming from InfoWorks, we did our business feasibility study over there, we went a bit further detail planning into Civil 3D, that information can be directly brought into InfoWater Pro or ArcGIS Pro, anything. So all of this is directly interoperable with other Autodesk softwares. That is what they've made it as easy as possible to happen, as well as the data transformation between these is also very seamless. There's no setting up of a JSON file to match your different parameters to the different file formats. This is seamless integration, just like you would with any standard Autodesk software.
So similar to how Autodesk Construction Cloud works for the construction process, it's the same process that we've got here.
That's correct, yes.
Okay. The last question here is, can you provide an example of a real-world application for InfoWater Pro?
Well, I think we've just had one.
Yeah, we've had quite a few that
we've just looked at it. But I mean, even doing something like not even looking at a burst, but just standard maintenance of flushing of a hydrant system. The council, in a real life situation, can go, all right, I'm going to start from the left-hand side of my working area, and I'm just going to go through my network and flush it to the right. So you can actually then start using and running simulations to simulate, all right, if my team starts on week 1 over here, and you can actually track their progress through the network as this goes along. So that's one of the real-life scenarios. And like we even mentioned earlier with the fires, that's another example we could use.
Yeah, excellent. And there are some fantastic examples on the Autodesk website of how this has been used across the region. And in fact, with all the recent flooding in Saudi and the flooding in Dubai, InfoWater Pro has been deployed and implemented through these cities to actually start managing their processes and their flood controls and all of their systems that they're running there. So very important and a lot of traction globally for this technology.
We could even add one of our local municipalities that we are currently in talks with is that, they've been able to preemptively see how they've had sabotage on many of their networks.
Mm.
So they were able to use ArcGIS and the AWI products to actually locate the area in which the problem was originating from, and then be able to protect that system a lot better using that data.
Yeah, very good example. So Jason, thank you very much for your time today. We're going to move across. Is there one more question? Sorry, we got a question here from Tabo. What are the common errors or issues that users encounter when using software, and do you offer support?
Oh, so generally the biggest thing is because you're moving over from a drawing database over to a standard GIS database, manipulation of that data. So databases are a lot more text-based formats. So you'll start using SQL queries and stuff like that to work with operability of the information between your different databases. So that's normally one of the biggest issues, especially with newer users. And yes, that is something that we do provide our clients with, is we have a fantastic support line. So whether it be for any industry, any discipline, we have the right specialist in-house, and we are able to assist with any project issues in the future.
Yeah, and I think what Autodesk have done very cleverly here is they've built a library of content that you can actually go and watch, and you can subscribe to teach you how to deal with issues. So you can self-paced learn, which is really a powerful tool that they've got there.
That's so true, yeah.
And I think moving from that drawing to a database is a transition that many of our customers have gone through when they were moving from AutoCAD to Revit. And that once you've learned how to do it from a database perspective, you'll never go back to drawing, because it is so much easier. Once you've got the database set up, you can start replicating and using that information into the future. We have a question here from Amar. Do you want to read it?
Would you use this on projects larger than IDAS can handle, or can IDAS manage the same project size projects? Great question, Amar. So IDAS, you can work around it. Using your data shortcuts and your network elements, we can work around it, but that is exactly why AWI has been launched, and where it comes from is exactly for that reason. When we start working with files that are too large for Civil 3D infra works, this is where we'll move over into AWI, whether it be a infra drainage or ICM.
Yeah, and it just depends on the type of project that you're working on. Last year, I met with a customer that was doing an analysis of a river system. They told me that doing it the traditional way took them 2.5 weeks to do the work. And they were using infra drainage, and they were able to do it in 2.5 hours. Because it's designed to handle large models. And that's the secret behind the technology, is that it is a workflow and an entire ecosystem. So whether you're doing, one segment of a river, or an entire river system, or you're doing a sewage network, it is designed to handle that entire size of that project. So yes, very scalable and focused on delivering high quality deliverables.
I'm actually glad you brought up the rivers, because I mean, that's something I also find very fascinating with infra drainage and ICM, is the new data and the operating engine that the software uses to do these calculations. They've improved that drastically from the previous versions. Now, something as small as the terrain meshing within ICM is something that's so big, because it's got a small feature where we want more detail on the river embankments. So it actually generates finer triangles that we have a lot more accurate elements into that. So it's small things like that that AWI have been able to bring to the table to make our life easier, and to help us take the next step forward into the future, for future proofing into how this company itself actually works with this data, and how we go from feasibility all the way down to construction, and what is going to be the most efficient steps for each process in between.
And I think the crucial bit that you mentioned there is the data. So making sure that the data that's been done in the design or the planning phase is still available at the end.
That is so true.
That is the crucial bit, and that's why the water lifecycle is so important to Autodesk, that when you're starting the planning process, the same data flows through to the end, so that when you're redesigning or you're making changes, that data is live and you can see all the inputs that were taken through. Sorry, excuse me. So I think that was the last of the questions. If you'd like to please give us some feedback, we'd love to hear from you guys. There's a QR code on the side of the screen here. If you just use your phone, that'll take you to the feedback. We'd like to know, how did you find the event? What did we get right? What did we miss? Is there stuff that we didn't cover and you'd like to hear more about? And if you'd like us to come and visit you and talk to you about our technologies, we're welcome to do that. In closing, Jason, is there anything you'd like to say?
I just want to say thank you everyone for your time. Much appreciated. I hope this was informative and we got the answers and piqued a bit of interest. And I hope to hear soon from you guys.
Excellent. Well, thank you very much. And thank you to the organizers and looking forward to hearing from you in the future.
All right.
Thank you.
Thanks, Simon.